Hello students, in the last video we discussed about the equations of kinematics or the equations of motion in one dimension, means the body is moving in a straight line with a uniform acceleration, and we got the equations of kinematics, we derived the equations of kinematics. So if I recall, the equations of kinematics are, one is v is equal to u plus at, final velocity, u is the initial velocity, a is the acceleration and t is the time. Then s distance travelled or displacement, you can say ut plus half at square, and the next one is your v square is equal to u square plus 2as, or v square minus u square equal to 2as, that we have derived. Then the next one is the distance travelled in the nth second or the last second is equal to u plus a by 2 into 2n minus 1. So we got these relations, and from these relations I discuss one of the best, the stopping distance from here. After what distance, if you suddenly apply the brakes or if you give a retardation, then at what distance the body will stop, right? At what distance, after traveling what distance, applying the retardation or opposite to acceleration, applying the opposite to the acceleration, and the body cover a distance and stops. How much distance it covered, that distance is called stopping distance, that we discuss. Similarly also you can see here, if a body starts from rest, from here also we can discuss one thing is, suppose a body starts from rest, so your s is equal to half at square. Why? Because u is equal to 0. Body starts from a rest, so u is equal to 0. So in this discussion, what we got here, acceleration is uniform, so s is proportional to t square. From here, s is proportional to t square. It means what? So we can say that the ratio of the distance covered by a body in 1 second, 2 second, 3 second, like that. What is the ratio of distance covered? So suppose in 1 second s1, in 2 second distance travelled is s2, in 3 second s3. So this equal to proportional to t square. So proportional to t square means we can say for 1 second 1 square, for 2 second it is 4, for 3 second it is 9, like that. So the distance travelled by the body in 1 second, 2 second, 3 second are like 1 is to 4 is to 9 if the body starts from rest. Similarly, if you see this part, if what is the distance travelled, if the same body starts from rest, then your ascent, the distance ascent is proportional to, if this is 0, then ascent is proportional to 2n minus 1. As acceleration is a constant, so ascent is equal to, this is 0, this is constant, so we can say ascent is proportional to 2n minus 1, or ascent is equal to a by 2 into 2n minus 1. So if we take this is a constant, so ascent is proportional to 2n minus 1. So if I ask you, what is the distance travelled by the body in the first, in the second and in the third, like that, first, second and third second, what is the distance travelled in the last seconds? These are the nth second, first second, second second, third second. So that we can say that for first second 1 and is equal to 1, so 2 minus 1, that is 1. For second 4 minus 1, that is 3. For third second 3 and is equal to 3, so 6 minus 3 into 2, 6 minus 1, that is 5, and so on. So these are the ratio of the distance travelled. So these things we discussed in the, from the equations of kinematics, we can get this concept from the equations. Now the next point is, my point is here in this video we will not discuss all these what we have derived, that for the application all these things, that is we will do in a next video. We will solve some problems using these equations. Now the next one is the one dimensional motion in a vertical line. Next is the one dimensional motion, one dimensional motion is the one dimensional motion in a vertical plane. means in a vertical line or in a vertical plane, or you can say in a vertical line also you can say. It is instead of plane, we can say in a vertical line. So this is nothing but that one dimensional motion in a vertical, this one dimensional motion in a vertical line, or this is also known as the motion under gravity. This is also known as the motion under gravity. Yes or no? So we will discuss in this video about the motion under gravity, what it means, or this is the nothing but motion under gravity. Now the question is, what is this motion under gravity means? So now you discuss these things. So what is this motion under gravity means? Now let us consider when a body is on the surface of earth, right, and if you throw the body to a certain height, then you throw the body, then the body comes to the surface of earth again. Why? Because of the force of gravity, that already you know that. Earth attract everything towards its center or towards its surface. So if a body goes up, earth attract that with a force, that force is called as the force of gravity. Yes or no? So it means when the motion takes place under the effect of this gravitational attractive force, the gravitational force is attractive, the body attracts this one. So when the motion takes place under the effect of this gravitational attractive force only, the motion is motion under gravity, and that is also called as the free fall of a body. That is called as the free fall of body. Means if I allow the body to fall, it fall because of the earth's gravitational force of attraction. So this motion is called a motion under gravity, or that is also a free fall. And during the free fall, no other force is considered. For example, while discussing all these things, we are not considering about the resistance of the air in the surrounding. Means if the body is falling, only the gravitational force is attracting this one? No, there is other forces are also acting. Suppose the wind is blowing, so wind has also applying some force, and there is some opposition to the body because of the medium in the surrounding. So the air medium is there, so the body is moving in the air medium, so it has some opposition by the air medium. So these are the factors are not considered under this motion under gravity. We will not consider these things. Only we will consider the body is falling under the gravitational force of attraction. And from where it comes? It is the Earth's force of attraction. That is the gravitational force of attraction. Okay. So it means, again I am repeating this thing, it means free fall does not mean that the particle is falling down only. Free fall means the particle does not falling down only. Even if the particle is rising up, or maybe momentarily at rest, or the particle is momentarily at rest, if it is going up or at rest, at a highest point. So when the particle goes up, so it comes to rest at the highest point. Means when if I throw a ball, the ball will go to a certain height. After that, at that height, from a height, it falls. It means what? I can say that where it falls, that the velocity is what? In this direction it is going, the velocity is in this direction, but it falls. Means the velocity becomes zero at this place. So means the body is momentarily rest at the highest point. Okay. So here, even if the particle is rising up or maybe momentarily at rest at highest point, but if only gravitational force is acting on it, then also this is also called free falling or motion under gravity, right? So now, according to this motion under gravity, when we are discussing the equations of kinematics, in motion under gravity, there we use the most important thing, that is the Sine convention. We use the Sine convention. While using the equations of kinematics in motion under gravity, we use the Sine convention. You use the Sine convention. So what the Sine convention we will discuss. So now you say that the body is under the gravitational force of attraction of Earth. So if the gravitational force of attraction acts on the body, and we are using the Sine convention, we use the Sine convention on what? The distance or displacement, the velocity, and the acceleration, because time cannot be positive or negative. So we will apply the Sine convention on distance or displacement covered by the body, velocity, initial maybe final velocity, or the acceleration. So now you discuss, now you think about what type of acceleration comes on the body, what type of acceleration is there in the body when the body is falling under gravity. So now you say here the equations, what the acceleration, what type of acceleration comes on a body when the body is under the gravity. The acceleration is called as acceleration due to gravity. That acceleration is called, the body has an acceleration under the effect of force of gravity, and the body is moving with an acceleration for freely falling motion. For freely falling motion, remember, for freely falling motion means the motion only because of the gravitational force of attraction of Earth. In that, the body has an acceleration, and that acceleration is called as acceleration due to gravity. Acceleration due to gravity, and generally we written this as g, acceleration due to gravity, g. And what the value of g? G is equal to 9.8 meter per second square. G is equal to 9.8 meter per second square on the surface of Earth we are considering. But further studies we will see that, we will say that this g is not always constant, it is maximum at this surface of Earth. When you goes up, g value decreases, and when you go down, g value decreases. Above the surface of Earth, g value decreases, below the surface of Earth, g value decreases. We will read in the different section in the different chapter. But my point is here, this g is near the surface of Earth. So we will always consider the motion near the surface of Earth. We will not consider the motion for a rocket thrown or a rocket projected from the surface of Earth, and the rocket is falling freely. On that case, we are not considering this one, because this is goes up or a long distance, it is away from so much distance away. So we are considering the motion near the surface of Earth. Up to a certain height we are considering. Okay. So now you go for the Sine convention. So under the motion of gravity, the body is moving with an acceleration called as the acceleration due to gravity, and this comes because of the force of gravitation of Earth. That is clear to all of you. I know that you got it from there. So now you use the Sine convention. So remember, we are dealing with what I told, that displacement, velocity, acceleration. These are the vector quantities. We are dealing with the vector quantities. When you are using the Sine convention, remember one thing, any vector quantity directed upward, any vector quantity directed upward will be considered as positive. Directed upward, positive. Any vector directed upward, any vector directed upward like this, velocity of directed upward, acceleration directed upward, or displacement directed upward, then any vector directed upward is positive. Like your coordinate system, when you are telling this coordinate system, because you are discussing about the motion of vertical line in this line, because this is freely falling, we are not considering the horizontal motion. This is the horizontal line, this is the vertical line. So in the vertical line, the body is moving, means in this direction it is moving, it is positive y-axis, negative y-axis. If the motion is downward, then it is negative. So any vector directed upward is positive accordingly. Remember, like it is very easy to remember like this. Then number 2 I can say, any vector directed downward is negative. That is the sign convention. Is negative. Is that clear? This is the sign convention. Okay. Now, if according to that, now will tell me one by one that the displacement is taken as, will be taken as positive. When we will take the displacement as positive. If the final position is above the initial position. If the final position is above the initial position, then we can say that the displacement is positive, like this. So the body is moving like that in a direction like this, up. The body is moving like this. So don't take this coordinate system. Let us, for displacement case, if the body is moving like this, upward, the final position, suppose this is the final position and this is the initial position. The body started from here and goes up, suppose. So the final position lies up to the initial position. So the final position lies above the initial position, right? In that case, the displacement is S is positive. Then what will be negative? If the final position lies below the initial position. So this is the initial position, this is the final position. So S is negative. So note down this one. Try to understand this thing. Okay? That is the concept we should understand while using the, while we write the equations of kinematics, we use these sign conventions. Okay? Next. Clear? Now, velocity may be initial or final velocity. Number 2 will be taken as positive if it is what? If it is upward. If the body is thrown like this, upward velocity, initial velocity is upward. I throw this body like this, or the body is falling like this. So this is the velocity. So if the body is going up, u is positive. Down, it is negative. So velocity is positive or negative, like that. Okay. And another thing very important, this acceleration. Acceleration here, remember this thing, the acceleration, that is the most important one. The acceleration, acceleration, or in short form I can write acceleration, is always negative. Means I will put in place of A as a minus g. Acceleration as negative. Why? As you know, when a body is falling freely, clear? So when the body is falling freely, the force of attraction, because of gravitational force of attraction, the body is moving. So in that case, the force is acting in downward and the body is moving like this. So here, the acceleration of the body is downward. So the direction is downward, always. If the body is going up, force is attracting force is downward. If the body is going up means nothing is taking, gravitational force is not upward. Gravitational force is always downward. So it is always, force is always downward. So the gravitational force gives you the acceleration due to gravity, and this is also downward. So that's why it is minus g. I will take this is always minus g. Now, with this sign convention, now I will write the equations of kinematics. Okay. So now the equations of kinematics, if we consider the motion under gravity, if I write the equations of kinematics under this, the equations of kinematics, the equations of kinematics are, what we will take, the equations of kinematics are, first v is equal to u minus gt, by considering a is minus g, by considering a is equal to minus g. Other sign conventions I have not considered. Then s is equal to ut minus half, in place of a minus g it is plus, so minus g t square. B square is equal to u square, yes it is plus, so minus 2gs. In place of a I will put minus g. Then Ascent is equal to, you can take u minus a by 2, so this is plus a by 2, this is minus g by 2 into 2n minus 1. So these are the equations of kinematics when we consider the motion under gravity. Is that clear? All of you got this one? So now we will go for the how to use the sign convention in different situations. How we will use the sign convention in different situations. Okay. Now we will go for that. Okay, students. Now we will go for some of the examples how to use this sign convention. So use of sign convention. Let me write here. Use of sign convention. Use of sign convention. How we will use the sign convention, then it will be clear for you. Now let us consider, in this case, let us consider three different situations. Let us consider three different situations, and in each situation, a particle is projected from a point A. A is a point. Particle is projected from a point A with initial velocity u and reaches point B after some time. And reaches the point B after some time. So let us consider three situations. Situation number 1, the body is projected and the motion is only under gravity. Now the body is projected like this. Clear? The body is projected with a initial velocity from the point A and reach at the point B. So this is the reach the point B and this is the point B. This line is the B with velocity u. With initial velocity is how much? U. It is projected from the initial velocity u. And in all the cases, this height is, let me take this height, make this height is common to all from A to B. From here, this height is h from the ground. So this suppose your ground. Clear? The body has initially what much velocity it is thrown from A, u velocity it is thrown from the A. This is situation 1. Now go to the situation number 2. In the situation 2, I will throw the ball and this is my position A, right? And here in the situation 2, the body is projected from certain height, already certain height A. Clear? Here the body is projected with a velocity u from here. So if you throw the ball from here, suppose the ball is thrown with velocity u, it goes to a certain height, then it falls like this and it comes to the ground, and it comes to the ground, and this is the point B. Clear? All these three cases are clear about you, right? And what is this height already? This height is your h. The body is thrown from a certain height, h height, it goes up, then it falls back because of gravitational, it goes up, where this gravitational force is more, then it fall down, reach to the point B. Then this is the situation number 1, this is situation number 2. Now go through the situation number 3. In this situation number 3, let the body is projected from A, here, A, and it comes to the ground like this. Here it is projected with velocity u and height is h, and this is point B. It is a fall like this. Fall like this. First case, see that simple example, sir. In the first one, this is your number 3. In the first one, body, suppose this is the ground, this is the ground level. Here you throw the ball and it goes to the height B. In the second case, at that height, you throw this ball, go some certain height, then come back. In the third case, the body is at this point and you throw this one like this. You throw. And the motion is under gravity. And A is equal to G. The body is moving with an acceleration, that is your G. Now, what we will consider and how the sign convention is used. So now we go for the figure 1. Displacement S. Here the displacement S will be taken as what? Displacement. Let me take this. Let me write what the notation we will consider. First one is the displacement. For all the three cases, first displacement we will consider. Clear? Then the next one is the initial velocity. We will consider the initial velocity. Initial velocity for all the three cases, and the next one is the acceleration. I will consider the acceleration. This acceleration is the acceleration due to gravity g. Now go for one by one. For the first one, what we will take? You tell me. You tell me. Displacement h. Yes, you are getting. Displacement h. For the case 1, going up, it is moving this displacement. It is the initial point, this is the final point, and displacement directed from initial to final. So this is a plus. So displacement is positive, right? Then what will be the initial velocity? The velocity is going up, so this is positive, u is positive. This is for case 1, u is positive. And obviously acceleration, it is always minus g, it is always directed downward. G is always downward because the force is attracting the body, and the body tries always to, acceleration is acting downward. It always retardation, the force due to gravity gives the acceleration which is retardation downward. For case 2, tell me, for this case 2, what you will consider? U going up, so for case 2, U is going up like this, but here it moves the h in this direction, h is in this direction, so this is obviously minus h downward. U goes up plus u, g minus g, always directed downward, so this is minus 3. Then in the figure 3, what about h? Minus h, clear, minus h, downward, the distance or displacement covered downward, u minus u downward, g minus g. This is the case. This is the use of sign convention. Okay, so these are the sign convention we use in different situations when the body is under gravity. So now in this case, if I will ask you, write the equations of kinematics if a body starts or from a height h falls freely. For a freely falling body, initially at rest, for a freely falling body. So this is the body, it is at rest, now I release this body. Release, I am not giving any velocity, just I release the body. The body fall automatically because the force is acting, the acceleration is there in this direction, directed downward. So this is also an example. Here the velocity initially is what? 0. But what is the acceleration here? G, it has an acceleration. So I will ask you an example. Get a question that give an example where the velocity is 0 and having acceleration. This is the situation. A body at a certain height or a body falling freely under gravity from rest. It is at rest and falling freely. If I leave this one, it fall. Okay, I am not allowed to fall this one. Then I have to take, again I have to write this using this pen. Okay, so if a body is released or dropped from a certain height, if a body is dropped from a certain height, if a body is dropped from a certain height, if a body is dropped from a certain height, or you can say from a certain or released from a certain height, then initial velocity is taken as 0. Then initial velocity u is equal to 0. Initial velocity is 0. Under this situation, equation of motion for freely falling body, the equation of motion. Now you tell me what I will write. You tell me. Equations of motion for freely falling body means the body is here and it is falling freely to the ground. It is coming to the ground. Here the u is equal to 0 and is falling with an acceleration is equal to minus g. Acceleration is equal to minus g. So what you will write here? So this acceleration, obviously no sign convention, acceleration equal to g, suppose I will take, or minus g you can take. So what are the equations? First one, b is equal to gt. If you use the sign convention, b is in that, body is moving in this direction, so b is downward, so this is minus, so minus get cancelled. So next, second one, s is equal to ut plus half at square, a is equal to g, so u is 0, so ut 0, so this is half gt square. Third one, v square, u square is 0, 2gs, both are negative. It is negative, this is negative, this is negative, all are negative. So no, I am not considering the sign. If you take the negative sign also, all v negative, g negative, s negative, S negative. If you put all these things, all will get the same equations. Then Ascent is equal to, then obviously the fourth one is the Ascent is equal to what? That is u is equal to 0, u by 2 is 0. So this is, u is 0. So next is the g by 2 into 2n minus 1. So these are the four equations. Okay. After getting all these things, now we will switch over to the equation of motion for a. So now we will go for the equations of motion, and by using these equations of motion for a freely falling body, or a body is moving vertically projected upward and it is under the action of gravity, then we will go for the sum of the expression from there. So now here equation of motions for vertically projected body. Now we will go for the equations of motion for a vertically projected body. So now come for the point. Now here we will find the equations of motion for a vertically projected body. Now do it first. Let us consider a body is projected vertically up. The body is projected vertically up. Okay. Let u is the velocity at the point A and it goes to the point B. But it is projected vertically up. And at this point B, the body is not coming at rest. Let the body is not coming at rest. The body at the point B is also having a velocity v. So this is u and the body has a velocity v here. B has a velocity, so it goes up. It is not reached at the point B, but I am considering point B during its motion vertically projected upward. So here, and obviously the height h, this is the height h. So now you apply the equations of kinematics. Then the initial velocity will be taken as what? What will be the initial velocity? U. Initial velocity, in this case, initial velocity plus u up, final velocity, it is moving upward. Velocity is there, the body is going up. So at that point B, I find this velocity is plus B. Acceleration minus g. Acceleration always minus g. G is always downward. Minus g. Distance or displacement. Displacement goes up plus h. Plus h. Okay. So this is the equation. So if you put these equations and if you write these equations, so in this case, what will the equations you will find here? What will the equations you find? If you put all these things, v square, v is equal to, what the equation you will get? V is equal to plus u plus minus gt, number one. Second one, s is equal to ut minus half gt square. Then third one, this because this s here s is h. Then third one, v square is equal to u square minus 2g h in place of sh. Then the fourth one, obviously Ascent is equal to, what do you write? U plus, so it is not plus, this is minus g by 2 because there is minus g into 2n minus 1. So these are the equations. So during this motion, if the body reaches the maximum height, in this case, if the body, let me write here, if the body reaches the maximum height means here the body stops, the body reaches the maximum height. It is think about this. So if I throw a body, the body goes up like, then at a certain height, are you doing something there? No, but the body fall. Why the body fall? During the projection, you are giving some velocity, the body is going with velocity u. This u goes on like this, that the u decreases when it goes up, because acceleration due to gravity is downward. So the motion is upward, g is downward, acceleration is downward. So this velocity decreases. So at a certain height, this velocity what you have given, it decreases and goes to 0. Where it is 0, the body has no velocity in this direction. What is there here? Only the acceleration in downward. Because of this downward acceleration, the body comes back with a velocity. From this, when the body comes down with a velocity, then you will find from the certain height where the velocity becomes 0, then when it comes down, the velocity increases. So with what velocity you have projected? With the same velocity the body will come back. When the body come back to your hand, or from where it is projected, you will come with the same velocity. Remember, number one. Other concept is that. Always remember this concept. Don't use like this, the wrong one. What the wrong one, generally the students are doing, what the mistakes. Then, when I project a body, it goes at right. At this point, the velocity is 0. Now when it comes and hit the ground, what is the velocity there? You are telling 0. No, the velocity is not 0 when it hit the ground. Because the ground has some resistance, the velocity becomes 0. If there is no ground, if the ground is lower than that, also the body will go. Means the velocity is not 0. The body has not the 0 velocity. Because of some opposition in the ground, the velocity becomes 0 and the body comes to rest. The body comes to rest, but it has a velocity. If you put velocity here 0 at the highest point, when it reaches the ground, velocity is 0. So here, u, suppose I will take this is initially u0, v0. So if you put any expression u0, v0, u0, v0, so 2gh, this is also 0. So h is 0, g is 0, all thing will 0. So that is not a concept. So don't use this concept. So when the body hit the ground, then the velocity is not 0. Because it hit the ground, its velocity, the body comes to rest. It has velocity. It has velocity. If the ground is not there, the ground is below that one, here the body hits, so it comes to rest. If the ground is here, the body comes to rest here. But the velocity is not 0, the body has velocity. Okay? So that is that. So if the body reaches the maximum height, means here this height, what will become v? This v will become 0. So v is equal to 0. This is a concept. Means when your final velocity, when you are projected with a body with initial velocity u goes on decreasing, at the final point, the final velocity v becomes 0, then the body falls down. So at this highest point, that is called the highest point. After that it will not go up. So this is the highest point. V is equal to 0. By that equations, by putting v is equal to 0, if you express these expressions, what you will get, and by putting this v is equal to 0, now I will find what will be the maximum height the body will go. In the same, okay? So the maximum in this case, now I will find maximum height attained by the body. That is a question. So here v is equal to 0. Now the situation comes here, v is equal to 0. Right? Now I will go for the expression for maximum height attained. In this case, but here v is 0. The body is velocity is final velocity 0. Expression for maximum height. You can take this as a problem also. Expression for maximum height. I have projected a body with a velocity u. The final velocity is 0 at the height, and it goes to the height, and this height is obviously maximum, h max. The body goes to the maximum height. Now I will find the expression for maximum height. So for this case, now you can explain this now. Let the body is projected from A with a velocity u, reach to the final point B, where the final velocity is 0, attain the maximum height h max, and the acceleration due to gravity acting downward. Okay. So in this case, by using the equation of kinematics, now use the equation of kinematics. V square minus u square is equal to 2gs. Now use this equation of kinematics. V square minus u square equal to 2gs. Okay, not 2s, but let me write the equation first here. But in this situation, now you tell me using the sine convention, all these things. Here, initial velocity. What is the initial velocity? Plus or minus, with sine convention. Plus you write. Final velocity. Yes. 0. V is 0 at the highest point. Height. How much height or displacement you can say, or distance you can say, because it's a straight line, the height attained or maximum distance covered. maximum height, maximum height, maximum height, h max, plus or minus, going up. Let me write like this so it is clear. H max, it is the maximum, h max, maximum height. Okay, acceleration, acceleration, minus g, obviously it is minus g. Put that, what you will get? Putting that, what I will get? 0 minus u square is equal to 2g minus d s h max, maximum height. So this is equal to u square is equal to 2g h max, or h max is equal to u square by 2g. This is the maximum height. H max is equal to u square by 2g. This is the maximum height attained by the body. Clear? Okay. So the maximum height attained by the body is equal to this much. First part is over. Clear? Now, suppose I will do like this same situation. If I will ask you with what velocity the body is projected from here, velocity with which the body is projected to go the maximum height, from the same expression. Remember, these are a problem like velocity of projection, velocity of projection. Velocity of projection means u. What is the expression for u? Velocity of projection, u is equal to 2g h max root over. This is the velocity with which the body is projected, right? Because u square equal to, from here, u square equal to 2g h max. If it goes to the maximum height, velocity of projection is here. This is velocity of projection to attain, you can add there, to attain maximum height, to reach the maximum height, not attain, to reach the maximum height, to reach the maximum height. H is equal, u is equal to root over 2g h max. Okay. Then next we will go for the velocity of projection to reach the maximum height. After that, if I throw in the same part, if we will reverse this case, if I reverse this case means if I throw a body with velocity u at this point, velocity u, right? Or suppose the body goes here, reach to this point, then come back, then what is the velocity at this point? Means the situation like that, the body projected from the point A goes to the maximum height B, then from there it come back. When it reaches to the ground, what is the final velocity? What will be the final velocity? Right? What will be the final velocity before touching the ground? Right? Here how we will find this one? What is the final velocity before reaching the ground? So here we will consider this situation. Here your initial velocity is 0 at the maximum height. This is the maximum height, h max. This is the maximum height. From this maximum height is projected, it goes from A to B. From here it comes back. When it reaches to the ground, what will be the velocity? When it reaches the ground, what will be the velocity? Here u is equal to 0. Now put that this one, v square minus u square is equal to 2as. Now here e is equal to 0. So now with what velocity the body is projected? So now the v is minus, body is coming back, so minus b whole square. Final velocity I want to find. Then 0 is equal to minus 2. A is equal to minus g. Then what is height? Height is in opposite, h max. So h max minus h max. So this is s is equal to minus h max going down. So minus plus. So this is v square is equal to 2g h max. So v is equal to root over 2g h max. V is equal to root over 2g h max. Now you got the same type of relation in this case. With what velocity the body is projected from here? Root over 2g h max. And it come back with what velocity? Root over 2g h max. So with what velocity I will project a body from the here, it goes to the highest point. Then if it come back at the same place where it is projected with the same velocity, it will reach the attain the same velocity. These are very important things. Okay. Now we will go for the time of ascent. In the same case, now we go for the time of ascent. Time of ascent means what? What time it will take to reach the highest point? Time of ascent. Time of ascent. What is the time of ascent? Means the time required to reach the maximum height by a vertically projected body. Right? The time required to, you note down this one. The time required to reach the maximum height. The time required to reach the maximum height by a vertically projected body is called time of ascent. Okay. Now in the same situation, let the body takes time, ascent case TA time to reach from A to B. That is the time of ascent to reach the maximum height. So in that case, now if you use the equation of kinematics, what the equation? I will find an expression for TA using the equation of kinematics, from equation of kinematics. From equation of kinematics. What is that? V is equal to U plus AT. Use this equation. V is equal to U plus AT. Now if you use this equation V is equal to U plus AT, then use the Sine convention here. So already I have used the Sine convention. So what you will use here? See, the final velocity is what? V is equal to 0. Yes. U is equal to what? Using Sine convention plus U. Acceleration minus g. Then the height attained, that is obviously a maximum height, that is your plus h. And time required is time is always plus TA. So by using this equation of kinematics, so what is your final velocity? V is equal to 0. U is obviously a. And what is g? A is minus g, because acceleration always g minus t. So t is equal to TA. Time required is TA. So I can write this as u is equal to g TA. So TA, time of ascent, equal to u by g. That is the time of ascent. With time ascent u by g. Similarly, what is the time of descent? Time of descent. What is the time of descent? Let TD. Means it goes to this height, let it come back with a time TD. With a time TD. Then here, how I will use this time of, how we will find the expression for time of descent. Time of descent means after reaching the maximum height, the time taken by the body to reach the ground from the highest point. To reach the ground from the highest point or the maximum height is called time of descent. So here again you will use the equation. First I will use by using the equation of kinematics. From equation I am not writing all these things. S is equal to ut plus half at. So put for this equation. So what is the s? S distance is your h max. Obviously h max. So you are finding this time. So h max is obviously downward minus. Then u. So when the time of descent is there, so when the body is coming, then what is its u? U is what? 0. Here the initial velocity is 0. When the body is projected downward, coming down. So downward means u is 0. So this is 0. Plus half a is equal to minus g. So plus and minus g t d square. So t d square is equal to 2h max. 2h max, minus obviously can cancel. This is 0. So 2h max by g. Then as you know, td square is equal to 2 by g. What is your h max? Maximum height expression. Tell me. What is your maximum height expression? Already you have derived. Yes. U square by 2g. You have to remember this thing. H max equal to u square by 2g. Already in the first expression, maximum height, u square by 2g. So this 2 get cancelled. So I will get td square is equal to u square by g square. So Td is equal to u by g. Td is equal to u by g. Okay. So now in this expression, so u by g. So we find that in these two cases, the time of ascent is equal to time of descent, that is equal to u by g. That is equal to u by g. So what is the time required to a body to reach to the maximum height? That is same equal to the time required to reach from the maximum height to the ground. So time of ascent equal to time of descent for the vertically projected body or a motion under gravity. What is the total time of flight? Total time of flight, Ta plus Td. Yes, very good. So total time of flight is Ta plus Td. Okay. So time of flight, that T is equal to, I will take Ta plus Td. What is the time of flight? That is equal to u by g plus u by g. So that is T is equal to 2u by g. That is the time of flight. So the time of flight means how much time the body is above the surface of earth, or from the ground. The total time is the time of flight. So okay students, we have discussed, you can say these are the numericals also, you can say these are the application numericals, motion under gravity. Okay, thank you. Go through the video and you will understand the topic more clearly. So remember one thing, here we are discussing kinematics and further we will go for dynamics. Here more and more concept is required. Try to understand the thing more clearly and try to go line by line in your books. Okay, every line has a concept. Okay? Thank you.